Hello Math 8 students. This lesson is graphing lines in standard form. This comes after we've spent a couple of days practicing graphing in slope-intercept form, and so we're going to change it up. And what happens when lines are given to us in a different format? Can we still graph them? The answer is yes, we just have to use some different strategies. So to review, let's look at what slope-intercept form really looks like. It's y equals mx plus b. Some things that we pointed out last time is the y is alone. It's in the format y equals. And the m is not really going to be an m, it's going to be a number. What does that m actually represent? The number that's in place of that m, what does that represent? I'm looking for hands now. We should be engaged learners here. What does the m represent when it's in this format? Thank you, that is much better. Emery? Yes, the m value is the slope. The b, the number that I'm adding, or in some cases subtracting at the end, what does that b represent? Jaden? Y-intercept. And so with that in mind, it's very easy to graph lines that are in this form because all I have to do is first identify the y-intercept. That's a +1, so I'm starting on the y-axis at +1. And from there, I use the slope, which is -2 in this problem. Rewrite the slope as a fraction so I can see the rise and the run, and then I can find other points. Oops. So starting at that +1, I would rise a -2, which means I'm actually going down, and I would run a +1, so I'm going to the right. There is another point on the line, and I repeat that process. Rising -2 and running +1. We can find multiple points on that line. We always want to make sure that we draw our lines going from edge to edge and being really precise, adding those arrows at the end, showing that that line extends. Another example that we have is the y-intercept here is -3. So on the y-axis, I'm going down to 3. That's where I'm going to start that graph now. I can see that the slope is a fraction, 7/4. And a lot of times students get afraid of fractions, but fractions when it comes to slope is the best thing because it tells me exactly what the rise is and what the run is. So from that -3, that's my starting point, I'm going to rise 7. 1, 2, 3, 4, 5, 6, and 7. And I'm going to run 4 in the positive direction. 1, 2, 3, 4. Even though I like to get multiple points on the grid before drawing the line, sometimes that's the best that we can do is just 2. If I tried to repeat this and go up another 7 and over 4, I'm going to be off the grid. If I try to go backwards from here and go down 7 and back or left 4, I'm also going to be off the grid. So best that I can do is just going through those 2 points. So I'm still going to try and do it as precisely as possible. Finishing up that line with arrows on each end. There's your quick review. Now let's look at some vocabulary. We have focused a lot on the y-intercept. I also want to talk about the x-intercept. We have seen it a little bit. We saw it yesterday, but I want to focus on what they each mean. So let's start here with the y-intercept, the most familiar. What is a y-intercept? Turn and tell your neighbors first so that you're ready to discuss as a whole class. What is the y-intercept? And so what is a y-intercept? Come and tell me now. Sam. Yeah, I'm only going to change one word. It's not where the slope, it's where the line. Yeah, where the line intersects the y-axis. So with that same concept, with that same idea, an x-intercept would be what? What would the x-intercept be? Let's go Brock. Exactly, where a line intersects the x-axis instead. So I have these 2 blank grids so that we can look at what a y-intercept really could look like. There is no specific line that I'm graphing. I just want to know, could this be a y-intercept? No. Why not? Yeah, it's not on the y-axis. So could this be a y-intercept? Yeah. Could this be a y-intercept? Yeah. Could this be a y-intercept? Could even this one be a y-intercept? Not even at a crosshair point. Yeah. Will you please write the coordinates for each one of those? What are the coordinates of this first one? Meaning like the xy, right? What is the xy coordinate pair for this point here? Thank you, Maverick. Yeah, 0, 4. And what about the xy coordinate pair for this one, Seth? 0, 0. How about this one here? Charlie? 0, -3. And this one, do your best. It's not going to be perfect, but do your best there. Let's go, Gracie. Yeah, 0, -5.5. What do you notice that they all have in common? Every single one of those. What do you notice? Ethan. The x is always 0. That's important to note, okay? Why is the x always 0? Turn and tell your neighbor, why is the x value always going to be 0? Okay, and now tell me, why is that x value always going to be 0? Daxton. Yeah, it's staying on the y-axis, which means I'm never moving left or right. And that's what that x value tells us, is how far we're moving left or right. It's always on that y-axis, so it's always going to be an x value of 0. So the x value is always 0. Let's switch over to an X-intercept. Could this be a possible X-intercept? Why is that not going to work? It's not on the x-axis, right? Let's move it then. Could this be an X-intercept? Yeah. Could this be an X-intercept? How about this one? Let's do one more. How about this one? Yeah. Let's write the coordinate pairs for each one of those as well. Maverick, go ahead. This one. Yeah, -3, 0. And what about this one here? Brock? -1, 0. Danielle, give me the next one. 1, 0. And the last one, Seth? 5, 0. Good. What do you notice about each one of these? What do all of these possible X-intercepts all have in common? Turn and tell your neighbors. And now back to me. What do they all have in common? Let's go with Emery. Yeah, the y-coordinate is always 0. So we're going to write that down as well. Y value is always 0. And again, why is that happening? Why is the y value always 0? That first coordinate, the x1, tells us how far left or right I'm going. Hold on, my mouse disappeared. Yeah, tells us how far the left or right we're going. The second one tells us how far up we're going. And if I'm staying on the x-axis, I'm going to be going up or down 0. So it makes sense that that y value is always going to be 0. That's going to be really, really important. Let's do a couple of examples though. Sometimes you can graph a line by just knowing where the x and y intercepts are. So moving on to the next one, it says the x-intercept is -3. Let's plot that point first. That means on the x-axis, I'm going to find -3. Found it, plotting that point. The y-intercept is -1. Where is that? On the y-axis, there's the -1. Can you plot or graph the line that goes between those points? Yeah. Don't just do this. Make sure that you're using your ruler and you're extending it beyond. Oops, that didn't work out. It needs to go through those points, but it still needs to go edge to edge just like we have done before. So yes, it should go through those points, go from edge to edge, and as always, include those arrows showing it extends beyond. Pretty easy to just graph the x and y intercepts, right? Okay, practice one more. I don't care which one. Anything you don't finish in class is going to be homework, so decide which ones you want to work on right now, and we're going to pause recording as students work on a couple of those problems. Okay, moving on. Again, anything not finished in class is going to be homework, so if you have not finished 4, 5, and 6, make sure you work on those for homework. Let's move on, though. Standard form of a line. It looks like this. A x plus by is equal to c. Just understand that in this form, first of all, a, b, and c are all going to be numbers. What do you notice about this form of a line? Here is the standard form where I kind of am using extra variables in place of some numbers. Here's an actual example, 5x plus 2y is equal to 10. Turn and tell your neighbors what are some things that you notice about standard form of a line as it compares to slope-intercept form of a line. Turn and talk to your neighbors. Okay, now come back to me. What are some things that you notice, especially as it relates to slope-intercept form? What are some things that you talked about at your table? Daxton, thanks for getting us started. Yes, yes. So if I go back to slope-intercept form, like y equals mx plus b, we're used to only seeing an x with some other numbers. And now we're seeing x with a number, y with a number, and it's equal to 10 instead of being equal to y. Weird things happening. Brock, what else do you notice? Good connection. You say, hey, we just did stuff with X and Y intercepts. I wonder if we can do stuff with X and Y intercepts here. We can, and we'll get there. Yep. Any other thoughts? Is the y alone when it's in standard form? Is it? Y is all by itself? Looks like y has a b with it and an ax with it. Is y alone? No. Was y alone in slope-intercept form? Yes. So that should be one of the major differences that we see. Let's maybe write that down. In this format, y is not alone. In fact, not only is y not alone, x and y are on the same side. So that is going to be one of the first things that I want you to look at whenever I give you a problem. Identify what form it's in first. Because if it's in slope-intercept form, it's easy. You can go straight into graphing. In standard form, it's not as straightforward to graph. You still can. It's just going to be a couple of extra steps. So let's practice this with this problem. I'm going to solve this problem 2 ways. Okay? I need you to graph the line 5x plus 2y is equal to 10. Let's first recognize this is in standard form because I can see x and y are on the same side and y is not alone because it's on the same side with the x. So recognize this means this is in standard form. So how am I going to graph this? You have two options. Option 1. Remember how slope-intercept form is y is alone? Your first option is solve for y. If we solve for y, y is going to be alone. And then it's going to be in slope-intercept form. Now, we have solved equations before. We haven't solved equations that have multiple variables, so this is going to be new, but after a little bit of practice, you're going to realize that it's really actually quite familiar, and we've done a lot of things similar to it. So let's start by making a flow map. This time we're going to be asking not what's happening to x as we usually would, but since I want to solve for y, I want to ask what is happening to y? What's the first thing that's happening to y? It's multiplied by 2. Yep, we multiply it by 2. After y was multiplied by 2, what else is going on? Maverick. Yeah, we're adding 5x. We don't care that the 5 and the x are multiplied together, because we're not worried about what's happening to x, we're only worried about what's happening to y. Oops, sorry, that should be times 2, and then we add 5x. So when I do those things, it's equal to 10. Now let's figure out, how do we undo things? How do I undo adding 5x? Yeah, we're going to subtract 5x. How am I going to undo multiplying by 2? Divide by 2. So now we know exactly what we need to do. Let's do it. We just need to make sure as we do it, we're really careful about one thing in particular. What is the first solving step? What do I want to take care of first? I want to subtract 5x, right? Okay, so let's subtract 5x. What is 5x minus 5x? Yeah, it zeroes out. But whatever I do to one side, we have to do it to the other side. So 5x minus 5x zeroed out. What is it that I'm left with now? 2y. And it is equal to, on the other side, we have 10, subtract 5x. What is 10 minus 5x? Be careful how you answer. Let your brain do the thinking first. What's 10 minus 5x? Go ahead and answer now. Let's see the hands. Fits? Oh, okay. Yes, tricky. Yes, it is equal to 2y. But what does 10 minus 5x simplify to be? Maverick? It is not. It is not 5 or 5x. It's been a while since we solved equations, but you should still be able to do this. How would I represent 10? That would be with 10 unit tiles. How would I represent minus 5x? Can we combine those things? Are these like terms? No, so what's 10 minus 5x? Seth? Exactly, it's 10 minus 5x. I know that 10 minus 5 is 5, but 10 units minus 5x tiles, that is not going to be 5, nor is it going to be 5x. Okay, so make sure you're understanding that concept that we talked about all the way back at the beginning of the year. These are not like terms, we cannot combine them. So is this as simplified as it's going to get? Yeah, and that's okay. Have we now subtracted 5x from each side? Yeah. What's our next solving step then? Divide by 2. So let's divide each side by 2. Remember, I just said let's divide each side. So I am going to divide the whole entire side. However, I am going to do it in pieces. It is okay to say 10 is going to be divided by 2 and the negative 5x is going to be divided by 2. I'm dividing the whole side by 2. I'm just doing it one piece at a time. 2y divided by 2, that divides out, and I am left with just y. Yeah, y is now alone now. What is it equal to? What is 10 divided by 2? 5. What is negative 5x divided by 2? Okay, but, this is all true. Let's go back. What is it going to be if it's still multiplied by x? It's our slope, right? And how do we feel about slope when it's a decimal? Isn't it better if it's a fraction so we can see the rise and the run? So, answer again, what is negative 5 divided by 2? Siley? Yeah, 5 over 2, negative 5 halves, exactly. So, this negative 5 halves simplifies to negative 5 halves multiplied by x. Maybe it's in a little bit of a different order, but can you still see the slope and the y-intercept right now? Yeah. If it helps, maybe you can even still switch it, because we can rearrange the order as long as we're careful. This is plus a negative 5x, plus a negative 5 halves x. So if I'm going to rearrange it, that would be a negative 5 halves x plus a positive 5. Y-intercept then is 5, and the slope is negative 5 halves x. Let's graph that now. We know that the y-intercept is 5, plotting that 0.5 on the y-axis. And from there, I need to use this slope. A slope of -5/2 means I can have a rise of -5 and a run of 2. Or I can have a rise of 5 and a run of -2. So falling 1, 2, 3, 4, 5, and running +2. If I tried to go up 5 and back 2, I'm going to end up off the grid. So let's do one more point. Falling 1, 2, 3, 4, 5, running 1, 2. And there's the line. Yes, Luke. Yes, you do. Yep. You act like it's a lot. You used to solve like 30 equations. And now I'm asking you to do 12. It's not that much work. There's option 1. We know how Luke feels. Luke doesn't like it. He doesn't like option 1. Maybe Luke will like option 2 better. Let's see what option 2 is. Let's recap though. Was it multiple steps? Yeah. Was it hard? No. Does it take some time? Yeah, it's not quite as straightforward as, ooh, y-intercept, ooh, slope, done in 2 seconds. It does take some thought process. It takes a little bit of showing your work, but it's not a hard or really even a new concept. Let's look at option 2. Maybe you'll like it better, maybe not. Let's review X-intercept. What is something that I know about X-intercepts? X-intercepts are on the x-axis, but what do we know about X-intercepts? Seth? The y-coordinate is always 0. So, in option 2, we can just graph the x and y-intercepts, but we still have to do some work to find those. For the x-intercept, we have to remember that the y value is 0. That's going to help us. Without me having to flip to the other slide, what do we remember about y-intercepts? What do we remember there? Jaden. Yeah, the x value is going to be 0. So with that in mind, if I want you to find the x-intercept, all you have to remember is the y value is 0. So you know what that means? Set the y value to 0. If we know the y value is 0, then we can solve for x. Watch what this really truly looks like, okay? I'm going to change the y value to 0. So what happens to that equation? It's 5x plus 2y, but 2 times 0 is 0, exactly. So 5x plus 2 times 0 is equal to 10. And again, you just told me 2 times 0 is 0. I'm going to show a lot of work and you're going to feel like it's unnecessary, and it might be, but I want you to just bear with me this time. So 2 times 0 is 0. What's 5x plus 0? 5x plus 0 is 5x, right? So in one step, and yes, I took multiple steps to show it, really truly, when I multiply by 0, when I multiply anything by 0, it goes to 0, which means I'm adding 0, which means I'm left with just that first term. 5x is equal to 10. Can you finish solving that and tell me what the x value is? Okay, divide each side by 5, right? And we get, I should do that in a different color. Yep, x equals 2. What does that mean? A couple things. Remember, each pair of coordinates is an x value, y value. Remember how I told you at the very beginning the y value is going to be 0? When I set the y value to 0, it allowed me to focus on the x value. What is the x value? 2. Can you plot that point? Okay, over 2, up 0, there's my x-intercept. We're not done. We found the x-intercept, we graphed it, put it on the graph. We still need to figure out what the y-intercept is. How do we do that? Well, we remember that for y-intercepts, the x value is 0. So set the x to 0. What does that look like? 5 times x now becomes 5 times 0. And 5 times 0 is, of course, 0. And 0 plus 2y is 2y, exactly. 2y plus nothing is still just 2y. So I'm showing a couple of these extra steps just so that you understand what's happening. I will not require you to show those extra steps if you can do it without making mistakes. What happens now? 2y is equal to 10. Can you solve for y to figure out what the y value is? Divide each side by 2. And you get y is equal to 5. So again, let's recap. What does that mean? Every coordinate is an x comma y. I told you in the beginning the x value is 0. And once I knew the x value was 0, I was trying to focus and just find the y value. What's the y value? 5. Can you plot that point? Over 0, up 5. Same exact line as before, because it was the same exact problem as before, but now you have 2 different ways of solving that problem. Let's just take a quick poll. Let's see, what do you prefer so far? Who liked solving for y? Putting it in slope-intercept form. Let's see those hands up high. Okay, a couple of you. Who liked setting the x value to 0 and the y value to 0 separately, finding the x and y intercepts? Okay, most of you. Here's what you get to do. You are going to practice both for 3 problems. After you practice both for 3 problems, maybe you will change your mind, maybe not. But then you're going to finish the last 3 problems, solving them any way that you decide that you like. The truth is, in the end, I don't care how you get this graphed. I just want you to have some tools in your tool belt so you can graph it. We're practicing using those tools now so you can decide which one is your favorite. Should we try one more? Okay, option 1, I'm going to walk you through this one, and then I'm going to let you kind of practice on your own without as much guidance. Option 1, remember, is solve for y. So I have my equation, 3x minus 6y is equal to 12. I strongly encourage a flow map here. Maybe you can do it without. Since y is what I'm trying to get alone, do you see this pesky 3x over here? Let's get rid of it. How am I going to get rid of this 3x? Turn and tell your neighbors. How am I going to get rid of that 3x? Okay, how do I get rid of that 3x? What am I really going to do? Sam? Exactly, just get rid of it. How do I zero out 3x? By subtracting it. And whatever I do to one side, we do it to the other side, right? That zeroes out. Be careful here. When that zeroes out, what am I left with on the left-hand side? Exactly, not just 6y, but a negative 6y. What's that equal to? What is 12 minus 3x, Brock? You got it, 12 minus 3x. We cannot combine those, so that's as simplified as it can be. We have another step. How do I undo that y being multiplied by a negative 6? Divide by a negative 6. And whatever we do to one side, we have to do to the other side. The whole side, not just a piece, but all the pieces have to be divided by a negative 6. Here it's easy. Negative 6 divided by negative 6 divides out, leaving me with just y. 12 divided by negative 6, negative 2. Negative 3x divided by negative 6, and you have calculators, you can use the calculators. Negative 3 divided by negative 6, no, it's not positive 2, it's positive 1/2, yeah. 3 divided by 6 is positive 1/2 x. Maybe you want to make that change and flip it around so it's mx plus b, but hopefully this is enough. Can you see the y-intercept? Yep. What's the y-intercept? Negative 2. What's the slope? 1/2. So from here I go up 1 and to the right 2. Up 1 and to the right 2. Luke, was it really that bad that time? Not too bad. Maybe you're still going to prefer option 2, but maybe if we practice option 1 a little bit more, maybe you'll decide that it's less work. We'll just keep on practicing and see. Okay, option 2. When I use option 2, you have to remember we have to do this twice. We have to do once where we're finding the X-intercept. Let me do that in purple. Once where I'm finding the X-intercept, and once where I'm finding the Y-intercept. X-intercept. What do I remember about X-intercepts? Turn and tell your neighbors there should be more hands. What do I remember about those X-intercepts? Okay, and I heard it almost in unison. We remember that the Y value is 0. So let's write that down. We remember the Y value is 0. So that means when I take this equation, the 3x minus 6y, guess what I'm going to do? Instead of y, I'm going to write 0. And again, I love doing this because what is any number times 0? 0. So what's 3x minus 0 going to be? 0. In one step, do you see how all of this of that equation zeroes out? So all I have is 3x is equal to 12. How do you undo x being multiplied by 3? We divide by 3, balance it, do the exact same thing to both sides. And now I have x is equal to 4. What does that really mean? Remember, we decided that the y value was 0. Using the y value of 0, I am looking for the x value that goes with that, and that is an x value of 4. So let's plot that point. Over 4 up 0. Hey, how about that? It shows up right there on the line. We already did graph it. Again, with now understanding the y-intercept means the x value is 0. So when I write this original equation, 3x minus 6y equals 12, I know that that's 3 times 0 minus 6y is equal to 12. And 3 times 0, I remember, is 0. 0 minus 6y leaves me with just minus 6y or negative 6y, which is equal to 12. We're going to divide each side by a negative 6 to get y by itself, and in doing that I have y is equal to negative 2. Not 2, negative 2. Recapping, every coordinate is an x comma y. I chose the x to be 0. Use that to help me discover that the y value is negative 2, and I can plot that point, which of course shows up on that line already. What questions do you have? Let's take another poll after one more practice problem. Who maybe thinks they like option 1 better? Okay, a few more are like, yeah, that wasn't too bad. Even Luke, you're a believer in option 1 now? Okay, option 2, who still is a fan of option 2? Okay. Keep on practicing, and maybe your mind is going to change, or maybe you're just going to say they're both just as easy as the other, so I like them both, and it depends on the problem which one I'm going to use. Here's one thing that I want to make very clear. So can I please have everyone's attention instead of you guys trying to work ahead? I want you to understand that this process of picking an x value and plugging it in is going to work no matter what x value we choose. Picking a y value, plugging it in is going to work no matter what. The reason why we choose an x equals 0 and a y equals 0 is because anything times 0 is 0. And it makes part of that whole equation 0 out. It makes it very, very easy. Let's see, let me decide what to do. What if, just for fun, what if I decide, let's make the x value be negative 6. Let's make the x value be negative 6. Will you guys do that with me? Just for fun, let's make the x value be negative 6. So let's go through that process. 3 times x, only x is negative 6, minus 6y is equal to 12. Still going to work, but what do you notice now? 3 times negative 6, is it 0 like it was before? No. So it's going to be extra work. But 3 times negative 6 is negative 18 minus 6y is equal to 12. You've got experience solving equations, so let's continue to solve for y. I have negative 18, which I'm going to zero out by adding 18. Same thing to both sides. Negative 18 plus 18 zeros out, leaving with negative 6y is equal to, let's see, 12 plus 18 is 30. Divide each side by negative 6. And I have y is equal to negative 5. Think about what that means. Remember, each one has an x comma y. What was the x value that I just randomly chose? Negative 6. What is the corresponding y value? Negative 5. Is that point on the line? Let's see, negative 6 comma negative 5. Negative 6 comma negative 5. Look at that. It's on the line. So can you do it with any x and y that you choose? Yes. Turn and tell your neighbor, why is it easiest to do it with x0 and y0? Summarize that. Okay, tell me, why is it easier to do it when we decide x is going to be 0 instead of x being negative 6? Why does that make it easier for us? Jaden? Yeah. It basically cuts our work in half because when I chose x to be 0, this whole term zeroes out. So I don't have to worry about adding or subtracting anything. I just have to go straight to that dividing. It makes our solving process much easier. Finding the x and y intercepts means half of that equation I need to solve zeros out. Okay, here's what I'm expecting. We are out of time. I wanted you guys to practice 8 and 9. And then do these ones for homework, but I think I'm changing my mind right now. Let's make 8 and 9 be homework. But I want you to do option 1 and option 2 for each of those. Is that fair? You don't need to worry about 10 through 12 right now. We'll save those for another day. Right now, I just want you to do 8 and 9 for homework, solving it option 1 and option 2 ways. That is it for today's video. Thanks for watching, and we'll see you next time.